This is Learning Assessment Problem 3.1. In this problem, we are requested to write the node equations for the circuit shown here, so the problem-solving strategy will be that of nodal analysis. The reference node has been chosen, and we have the two node voltages labeled V1 and V2. So recall that in the nodal analysis approach, we are using Kirchhoff's current law to sum currents at each node and writing the currents in the passive elements in terms of the node voltages. So if we begin at node V1 and do a Kirchhoff's current law there, we have minus 4 milliamps plus V1 divided by 6K plus V1 minus V2 divided by 12K is equal to 0. We have three currents. We've written those three current terms in our Kirchhoff's equation. We have three currents, and we sum those in our Kirchhoff's current law equation. So simplifying a bit, we have V1 divided by 6K So simplifying a bit, we have 1 over 6K plus 1 over 12K times V1 minus 1 over 12K times V2 is equal to 4 milliamps. Or simplifying a bit more, we have 1 over 4K V1 minus 1 over 12K V2 is equal to 4 milliamps. So that will be our first node voltage equation. Performing a similar summation, KCL summation at V2, we have 2 milliamps for the current source plus V2 divided by 6K plus V2 divided by 6K plus V2 minus V1 divided by 12K is equal to 0. And simplifying this, we have minus 1 over 12K V1 we have minus 1 over 12K V1 plus 1 over 6K plus 1 over 12K V2 is equal to minus 2 milliamps. And simplifying a bit more, we have minus 1 over 12K V1 plus 1 over 4K plus 1 divided by 4K V2 is equal to 2 minus 2 milliamps. So that would be our second node equation. Now if we write these two equations in the matrix format, we have 1 over 4K minus 1 over 12K minus 1 over 12K and 1 over 4K times the voltage matrix V1 and V2 is equal to 4 milliamps minus 2 milliamps. And if you solve this by your favorite technique, we have V1 is equal to 15 volts and V2 is equal to minus 3 volts. If we write these two equations in the matrix format, we can solve for the two voltages V1 and V2. So this will be 1 over 4K minus 1 over 12K minus 1 over 12K and 1 over 4K times the two unknown voltages V1 and V2 times the two unknown voltages V1 and V2 is equal to 4 milliamps and minus 2 milliamps. So we have a matrix here which has units of conductance times voltage is equal to current. So that's the matrix equation. So we can solve this by whatever your favorite technique is, using MATLAB, Cramer's method, Excel, or perhaps your calculator. You will find that V1 is equal to 15 volts and V2 is equal to minus 3 volts.